This lesson is on section 4.6, congruence in right triangles. Do you remember the parts of a right triangle? The legs are the sides that make up the right angle, and the hypotenuse is the side that sits across from the right angle. It's also the longest side, which may have been something you've learned. We're going to combine right triangles with triangle congruence today. Do you remember the 4 ways that we have learned in this chapter to prove that two triangles are congruent? We have learned side, 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 angle, side, angle, side, angle, and angle, angle, side. There is a 5th way to prove that two triangles are congruent. This one is saved only for the use with right triangles. That does not mean that if you're given 2 right triangles and asked to prove if they are congruent that you cannot use any of the 5. It just simply means if you're going to use the 5th reason, which we call HL, if you're going to use HL as a reason, you have to have right triangles in order to use HL. HL stands for hypotenuse and leg. So it says if you can show that the hypotenuse and the leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then your triangles have to be congruent. This one is different from the other 4 in that it can only be used in right triangles, and if you notice, it only has 2 congruent parts instead of 3. The reason it only has 2 is because since it only works with right triangles, there is implied a set of right angles that would automatically be congruent. So the idea is you only need 2 more pieces to prove that the triangles are congruent above and beyond the right angles themselves. This is a good example of using hypotenuse leg. We are given that the hypotenuses of our 2 triangles are congruent. We can see that we have right angles. They are given to us by the squares. We know that those are right angles. And our 3rd piece that's congruent is segment GJ, and segment GJ is congruent to itself because of the reflexive property. So you can see that GJ is a pair of sides that we would call legs, and that GK and GH are congruent. They are the hypotenuses. So HL would be the reason that these 2 triangles are congruent to each other. Let's use the idea of a proof to show that these 2 triangles, triangle ABC and triangle DCB, are congruent. Reason number 1, we are given that angle ABC and angle DCB are right angles. So that would be our first example, that ABC and DCB are right angles. And that was given to us. We were also given that AC is congruent to DB. So we will put that in statement 2. AC is equal to DB, and that was given to us. In order to show that our 2 triangles are congruent, we have to have 3 parts. We have right angles. We have 1 pair of congruent sides. We actually have a 2nd pair of congruent sides. CB is equal to CB, and the reason for that would be reflexive. And so we have a pair of hypotenuses that are congruent and a pair of legs that are congruent. So because of HL, we can say that our triangles are congruent. So we can use our proof statement that ABC is congruent to DCB because of the HL theorem. Another way we can use the HL theorem is in this example, triangle XYZ is isosceles. It says the vertex angle is X, so I'm going to put X at the top. And it says a line is drawn perpendicular that means it has right angles, to YZ, intersecting YZ at point M. The question is, how do you know that triangle XMY is congruent to triangle XMZ? And the answer to that is, in the first statement, it says that XYZ is isosceles and that X is the vertex angle. So we know that XY and XZ are congruent to each other because of the definition of isosceles triangle. We can also then use the reflexive property to say that XM is equal to itself. So because of the HL theorem, these two triangles are going to be congruent to each other. So is YM and ZM congruent? And the answer would be yes. And how do we know once we show that two triangles are congruent, that other parts are congruent? And your answer would be CP-CTC. That's another way that you can use HL. You can use it with CP-CTC to find other congruent parts of triangles. If you are not in an honors class, then your homework is as follows. If you are in honors, I'm going to show you another kind of proof that you can use instead of the two-column proof in order to prove that two triangles are congruent, and then use CP-CTC if you need to. In a two-column proof, we are given statements and reasons, and we write our three congruent parts, and then we write our triangles are congruent. In a flow proof, you take each one of those statements and reasons, and each line becomes its own bubble. You'd write the three congruent parts in these three bubbles. Congruent part number 1, 2, and 3. Then notice the arrows all lead you to the next statement. It says once you fill these three bubbles, then that leads you to the fourth bubble. The fourth bubble is where you're going to write that your triangles are congruent. And your reason here will be one of the 5 postulates and theorems that we've learned in this chapter. Side, 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 angle, side, angle, angle, side, or hypotenuse, leg. Then if you need to go beyond congruent triangles, we learned in one section that once your triangles are congruent, you can say anything else is congruent, and your reason will be CP-CTC. So that's where this bubble would come in. After your triangles are congruent, then you can say that any of your parts are congruent, and your reason would be CP-CTC. You might be wondering what this other bubble is above that. That would be if you're given something that isn't directly a congruent piece, but that leads you to a congruent piece. So this would be where you would put if something is bisected, if something is parallel, or if something is a right angle. That's where you put that. It leads you to something that is congruent. You fill in your 3 congruent parts and your reasons, whether it's given or whether it's reflexive sides or whether it's vertical angles. Then that leads you to your triangles being congruent, which then leads you to be able to use CP-CTC. It works exactly the same as a 2-column proof. It's just a different visual aid. If you are in honors, your homework is such.